Good evening. We're going to start with Lesson 32 in Module 3. I can interpret and find whole number, quotients, and remainders to solve one-step division word problems with larger divisors of 6, 7, 8, and 9. Okay, in our example number 1, we all know that there are 7 days in a week. How many weeks are there in 259 days? Okay, so let's draw what we know and what we need to know on a tape diagram. So if I draw a tape diagram, mine always don't look the nicest, but it gets the job done. And this whole diagram represents 259. And we know that there's 7 days in 1 week, so let's represent one part of this tape diagram and put a 7. Because there's 7 days in each week. But we don't know how many groups of 7 there'll be. So all of this, we have no idea. So how did you know to represent the number of weeks that are an unknown? Well, I labeled the rest of the tape diagram with a question mark. So let's solve for how many weeks there are in 259 days. And how we're going to do that is that we are going to divide. Because we know that there are 7 days in a week, and we have a total here. So let's start division. So 259 is in our house, division house, and outside is the 7. 7 can't go into 200, so we're going to put an X. But 7 can go into 25, not evenly, but close to it. And it can go 3 times. So 3 times 7 is 21. The next step is that we subtract, and we're left over with 4. The next step is to bring down the 9. So now we have 49 ones. So 7 goes into 49, 7 times 7 is 49. We used up all the ones, and we're left with a remainder of 0. So there are 37 weeks in 259 days. Okay, and problem number 2. Everyone is given the same number of colored pencils in art class. There are 249 colored pencils and 8 students. How many pencils does each student receive? So let's look at those clues. Given the same number, so we're looking at an equal number of colored pencils. There are 249 colored pencils, so we're given a total. And there are 8 students. How many pencils does each student receive? So we have to use and draw a tape diagram. So I'm going to draw a tape diagram. And all of this is equal to our total of 249. And because there are 8 students, I need to make 8 groups. So I have my 8 groups in my tape diagram. But I don't know how many each of these students are going to get. I know there are 8 students, and I know they're going to get the same amount of colored pencils. So this student is going to get an amount, this student, they're all going to get the same amount in these boxes, because each one of these boxes represents a student. And they all equal 249 pencils. So we are going to divide. We got our total. We have for each student. We know we have 8 students, so let's figure this out with division. So 249 is in the house, and we're dividing by 8. 8 can't go into 200, so we're going to put an X. But then 24. We got 24 tens. How many times can 8 go into 24? Well, that can go 3 times. 3 times 8 is 24, and then we're going to subtract, and we're left with 0 tens. We used them up. We bring down the 9. We have 9 ones. 8 goes into 9 once. 1 times 8 is 8. And we have a remainder of 1. So our remainder is going to look like something like this now. So now our tape diagram looks like this. We have 8 boxes. But this little red box, that's not usually the size as the others, is showing me that there is a remainder 1. That means there is 1 pencil remaining. But I can't give that pencil out because each student is going to get the same amount of pencils. So I have to take and put that pencil away. So really, how many pencils is each student going to get? They're going to get 31 pencils because they cannot get that last remaining pencil. Now I want to make sure if my answer was right, I would check. And we always check with the inverse operation. That's multiplication. And we add on that remainder. Okay, problem 3. Mr. Hughes has 155 meters of volleyball netting. How many nets can he make if each court requires 9 meters of netting? So what we want to do is we want to look at the clues. And I see here we have 155 meters. We got the total. And I see the word each and requires 9 meters of netting. All right, so we're looking at a tape diagram. So let me draw a tape. And this whole tape is going to equal to 155. And we know that one of these sections is going to be a 9. But I don't know how much is going to be in the rest of this tape diagram. So we're going to have to do long division. So 9 can't go into 1, so we put an X. But 9 can go into 15, and it can only go in once. Because 9 times 2 is 18, and we're going over 15, so we can't do 9 times 2. We'll do 9 times 1. So 9 goes into 15 tens one time, get 9, and we are left with 6 tens. Then we bring down the 5, and now we are left with 65 1. So 9 can go into 65, 7 times. 7 times 9 is 63, and we're left with a remainder of 2. So now we actually have to show this remainder back in our tape diagram. And there we go. We've got our remainder in our tape diagram to model this question. So we have, so how much is going to require to make 9 meters of the netting? 17 meters. Okay, you guys give it a try. Menica bought a package of 435 party favors to give to the guests at her birthday party. She calculated that she could give 9 party favors to each guest. How many guests is she expecting? Make sure you are showing a tape diagram. And if there is a remainder, guys, make sure you go back in and place that remainder back into the tape diagram to model this question. So, I would really like to see your tape diagrams in tomorrow, so bring them in. All right, number 2, 4,000 pencils were donated to an elementary school. If 8 classrooms shared the pencils equally, how many pencils did each class receive? Be sure to create a tape diagram. And if there is a remainder, go back into the tape diagram and represent that in there. And I'd love to see your diagrams tomorrow. And our last problem tonight. 2,008 kilograms of potatoes were packed into sacks weighing 8 kilograms each. How many sacks were packed? Okay, again, this has to be demonstrated using a tape diagram. If there's a remainder, be sure to show that remainder in your tape diagram and bring them in tomorrow. Keep up the excellent work, guys. Have a wonderful night.